Rethinking the universe. Cracks in the cosmic clock, soft ambient music fades in, evoking a sense of mystery and awe. Just over a century ago, humanity's view of the cosmos was astonishingly small. Most astronomers genuinely believed that everything, every star, every planet, every piece of matter, existed only within the Milky Way. The idea that other galaxies might exist was almost unthinkable. But in 1928, one man changed everything. Through careful observation, Edwin Hubble discovered that the light from distant galaxies was stretched, redshifted, revealing that the universe was expanding. It was a moment that transformed human understanding. The cosmos was not static. It was alive, growing, stretching, evolving. Decades later, the Hubble Space Telescope carried that legacy into orbit. In 1997, it revealed something even more extraordinary. The expansion of the universe wasn't slowing down as expected, it was accelerating. That acceleration pointed to a mysterious, invisible pressure now known as dark energy, a force so powerful it dominates the cosmos, yet remains utterly unknown. From that discovery, scientists refined the age of the universe to about 13.8 billion years. For a while, that number seemed certain. But today, the story is changing again. M92. The cluster that shouldn't exist. Deep in the Milky Way lies a densely packed cluster of stars known as M92, one of the oldest known objects in existence. Its age? Roughly 13.8 billion years, maybe older. And that's a problem. By definition, nothing should be older than the universe itself. Stars form after the Big Bang, not before it. Yet M92 seems to challenge that timeline completely. Astronomers ran simulations of more than 20,000 star populations, trying to refine its age. The result hovered right on the edge of the universe's supposed beginning, or possibly beyond it. That single cluster forced scientists to ask a haunting question. Have we been wrong about the age of the universe all along? Then came Webb. The Webb revolution. The James Webb Space Telescope, the most powerful observatory ever built, looked deeper than any instrument before it, back to the dawn of time itself. And what it saw rewrote the script of creation. Webb detected fully formed galaxies appearing just 300 million years after the Big Bang, immense, bright, and structured. According to every current model, that shouldn't be possible. Galaxies that massive should have taken billions of years to assemble. So, what's happening? Are our measurements wrong? Or is the universe far older than we've been led to believe? Some physicists now propose a radical idea. What if the universe isn't 13.8 billion years old, but closer to 26.7 billion? This theory suggests that our models of cosmic expansion, galaxy formation, and even stellar aging are incomplete, or fundamentally misunderstood. The Methuselah paradox. There's another clue, hiding in plain sight. A star called HD 140283, better known as the Methuselah star, sits relatively close to Earth. Its estimated age? 14.5 billion years, nearly a billion years older than the universe itself. It burns slower, ages differently, and seems immune to the ordinary rules of stellar physics. If that estimate holds true, the Methuselah star may be a relic from before our universe as we know it, perhaps a survivor from an earlier cosmic cycle. The Hubble tension. At the center of all this confusion lies one critical number. The Hubble constant, the measure of how fast the universe is expanding. But no matter how precisely we measure it, the results don't agree. When we study the early universe using the cosmic microwave background, we get one value, around 68 kilometers per second per megaparsec. When we measure closer galaxies and stars, we get another, closer to 73. This discrepancy, known as the Hubble tension, isn't just a calculation error. It's a sign that something profound is missing in our understanding of spacetime itself. Perhaps dark energy isn't constant after all. Perhaps it evolves, changing strength over billions of years. If that's true, then our entire cosmic timeline could shift, rewriting how galaxies form and how we measure the age of the universe. What if everything we know about the beginning of time is wrong? For over a century, the Big Bang has stood as the defining origin story of our universe. The moment everything burst into existence from a singular point of unimaginable density and heat. But new discoveries from the James Webb Space Telescope are forcing scientists to rethink that story. Because what Webb is showing us doesn't fit. Across the depths of space, Webb has captured galaxies that seem too ancient, too massive, and too complex for their supposed place in time. Galaxies that formed mere hundreds of millions of years after the Big Bang, yet look as if they've been evolving for billions. It's as though these galaxies carry the memory of something older, something that existed before our universe began. The endless cosmos. This brings us to one of the most profound possibilities ever proposed. What if the universe has no beginning, and no end? An ancient idea, once considered fringe, is resurfacing with new evidence, the theory of a cyclic universe. In this model, the cosmos doesn't begin with a single explosion and end in silence. Instead, it breathes, expanding, collapsing, and being reborn in an infinite sequence of big bangs and big crunches. Each cosmic cycle gives rise to new galaxies, new stars, and new laws of physics, while echoes of the previous universe ripple through to the next. Could it be that the galaxies Webb observes, so old, so developed, are in fact ghosts of a previous cosmos, still shining through the fabric of our reality? Some physicists believe these echoes may even appear as tiny temperature fluctuations in the cosmic microwave background, faint fingerprints left behind by a universe that came before ours. The primordial architects. Then there are the primordial black holes, mysterious, ancient objects that might have formed just moments after the Big Bang, or perhaps before it. Unlike black holes formed from collapsing stars, these would have emerged directly from the quantum chaos of the early universe. They could be the hidden architects behind the structure of everything we see, seeds around which galaxies rapidly coalesced. If this theory holds true, these primordial anchors may have helped shape the early universe far faster than current physics allows. They could even carry information, the gravitational memory of a universe that existed before ours. The multiverse and the cracks in reality. But the mystery doesn't stop there. What if our universe is just one of countless others, part of an infinite multiverse, a vast cosmic ocean filled with realities born, dying, and colliding beyond our perception? If multiple universes coexist, their boundaries might occasionally blur. In those fleeting intersections, energy, gravity, or even matter could leak between dimensions. And when Webb peers deep into the ancient dark, perhaps what it sees, those impossible galaxies, those strange alignments, are the faint fingerprints of another reality overlapping our own. Quantum theory even hints that time itself may not be as stable as we think. In the earliest fractions of a second, time may have fluctuated, flickering like a faulty signal, starting, stopping, reversing, creating distortions we now detect as cracks in the cosmic clock. The great question each image Webb sends back challenges not only our mathematics but our imagination. It forces us to ask questions that strike at the heart of existence itself. What if the Big Bang wasn't the beginning, but just one frame in an eternal film of creation and destruction? What if the universe is far older, 26 billion years, perhaps infinitely so? And what if, somewhere in that infinite sequence, the story of our own universe has already been written, and will one day begin again? The James Webb Space Telescope may not be a time machine in the literal sense, but it is something just as extraordinary. It's a mirror, reflecting not only the light of ancient stars but the depth of our own curiosity. It's revealing that the cosmos is not a simple equation, but a living story, vast, cyclical, and still unfolding. Every photon Webb collects is a whisper from eternity. Every image a reminder that the universe is more than what we see, and perhaps, that creation itself never truly began, because it never truly ends. And so, as we stand beneath the same stars our ancestors once gazed upon, we're left with a question that may define the next century of science. If there was no beginning, what does that make us? A consequence of cosmic chance? Or the latest verse in a song that the universe has been singing forever? Because the deeper we look, the more it seems, the universe was never silent. It was always becoming.